Hi everyone, this is the first video for chapter 3, specifically sections 3.1 and 3.2. So if you haven't already, go ahead and go back and read these sections in the textbook, just so you know what I'm talking about. We're going to do a lot of examples today. So yeah, we're just going to do examples, so you should already be familiar with some of the vocabulary that we're going to use. So like I mentioned in one of the previous videos, in this video we're going to talk about adding and subtracting whole numbers, but at this point, you should know how to add and subtract whole numbers really easily. We've been doing it almost your entire life. So when something's so second nature to you, it can be hard to know how to explain this, which you're all going to have to do as future educators. So in order to remedy that, we are going to do operations in different bases, something that's probably new to you, so you remember what it's like to learn how to do these operations. Okay, so in section 3.1, the first part of it talks about using different models to add whole numbers. So one of those models is a number line, and we're going to go ahead and do examples of that. So the first thing whenever you're adding whole numbers using a number line is you want to draw the number line. So this first example, you can see it says pay attention to the base, but sorry, this first example doesn't have a base. So if it doesn't have a base, we're going to assume that it's base 10, right? So we're going to assume that if it doesn't have a base explicitly listed, that we're doing operations in base 10. So we just draw a normal number line. So yeah, the number line in base 10 is our standard number line, like so. So the number line, well, since we're adding things that are positive, we can just deal with those positive values, and the whole numbers are positive. So we're just dealing with things, and we can start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We're going to stop there at 14. Okay. So when we are adding things on this number line, we are going to, first off, represent the first number that we add. So that's 6. So 6 here stretches from 0 to 6, and that is 6 units. And so this line segment has length 6. It's not because it ends at 6, it's because whenever we count it, there's 1, 2, 3, 4, 5, 6 little segments in this whole line segment. So this has length 6. And now when we're going to add 7, we go another 7 units. 1, 2, 3, 4, 5, 6, 7. So now this one has 7 units, right? 1, 2, 3, 4, 5, 6, 7. So this one has 7 units. And so where did we end up? So we ended up here at 13. So we can say that 6 plus 7 is 13. And that's our answer. So this is our answer, and the number line above it is our work. So we do this exact same process in no matter what base we're in. So our next example is base 8. So the thing that's going to change is how we draw our number line. So let me draw that. So we're going to change how we draw our number line. So again, I'm just going to start at 0 every time. So 0. And then we're going to write down our digits. But remember, in one of the previous videos, we talked about the digits and the bases are different. So if we have a base that's less than 10, then our digits are 0 up to 1 minus that base. So we're going to go 0, 1, 2, 3, 4, 5, 6, 7, right? Because in base 10, we have digits 0 to 9. In base 8, we have digits 0 to 7. And then we're going to carry. So we have 1 8 and nothing else, because that 1 is in the 8's place. So we have 1 8 and nothing else, an 8 and a 1, an 8 and a 2, an 8 and a 3, an 8 and a 4, an 8 and a 5, an 8, and a 6, an 8, and a 7. And once we get to 7, we carry again. So now we have 2 8s. And that keeps going. So we're going to just do the exact same process. So we start here, and we have 6 units. So we have 1, 2, 3, 4, 5, 6. So you don't have to count them. You can just say 6. Oh, one thing I'm sorry I forgot to do is we need to make sure to label our number lines. So because this number line is in base 8, we need to put that it is a base 8 number line. And up here in our first example, we don't have to label that it's in base 10, because if it's not there, we're just going to assume it's base 10. But if it's not, you need to label it. Okay, so we had 6 units, and now we need to go 7 more. 1, 2, 3, 4, 5, 6, 7. So I'm gonna just count them down here for myself, so I know. Oh, see, I skipped 5. So that I know that I went 7 units. So that's 7. And where did we end up here? At 1, 5. So you may have noticed in previous videos, it's really common to just want to say 15 because that's what we're used to. But this value doesn't denote 15. It denotes 13 in base 10, but it's written in base 8 as 1, 5. So now we can say that 6 base 8 plus 7 base 8 is 15 base 8. So one thing on the notation here, if you're going to choose to write things down with the base being the numeral instead of the word denoting 8, you need to be very clear distinguishing between 68 and 6 base 8. I should be able to tell which one you're doing. That's just a little note for that one. So now, for number 3, we're going to do an example in base 5. So again, if our base is less than 10, then we have digits 0 up to 1 minus the base. So we have 0, 1, 2, 3, 4. And once we have 4, the next one, we're going to have 1, 5, and nothing else, a 5 and a 1, a 5 and a 2, a 5 and a 3, 5 and a 4. And once we have a 5 and a 4, we're going to have 2 5s, 2 5s and a 1, 2 5s and a 2, 2 5s and a 3, and then it keeps going. Okay, sorry, this number line is a little bit crooked. So now we are going to do the same thing. So we're going to go start at 0 and go 12 units over. Oops, that was a little bit too long. 12 units over. Oh, so you see here, yeah, 12 base 5. So we're not going 12 units. My apologies, because 12 in base 5 is really what? So we know that 12 base 5, written in the expanded form, is 1, 5, and 2 1s. So we know that this is really 7 units. So we go over 7 units here on our number line, and I'm just going to verify that again. So we go over 7 units to 1, 2 base 5. Okay, you got to be careful on that. So now we're going to go over 4 units because 4 in base 5 is equal to 4 in base 10. So we're going to go over another 4 units. 1, 2, 3, 4. Okay. So we went over 4 units, and where did we end up? Right here at 2, 1. So this tells us that 12 base 5, and I'm just going to write it in words so that it's clear, plus 4 base 5 is 21 base 5. Okay, that's going to be our answer. Okay, so now we're going to do a base that's not lower than 10, base 16, just a refresher. So remember, base 16 is also called the hexadecimal numeral system, just because that comes up. It's what people call it. So we're going to start the exact same. We are going to draw a number line, and we're going to start at 0. So remember that the digits for hexadecimal are the same. I keep skipping 5. So 4, 5, 6, 7, 8, 9. So they're the same up to 9, but once we get to 9, we start using the alphabet, remember? So we have A, B, C, D, E, and F. And then after F, we go back to having 116, and then we just carry at that point. So this keeps going. Okay, so if we want to go A16, so that means we're going to go from 0 over to A. This has length A. And then we want to go 7 more. So 1, 2, 3, 4, 5, 6, 7. So this is 7, and we ended up here at 1, 1. So we can say that A base 16, 16 plus 7 base 16 is 1, 1 base 16. So if you ever have trouble knowing how many units to go over, right, so A corresponds with 10. So we actually went in this example 10 units. So in this case, we actually went 10 units, but if you don't remember what A corresponds to, I would just translate it. So like here in example 3 we did, at 12 base 5, in base 10 is the amount of 7. So if it helps you, you can translate all of them to their expanded form and calculate them in base 10 to know how many different units to go over.